Hello, welcome again. We are solving some questions of manufacturing science or production engineering. The topic is metal cutting. Question number 54, 24 to 25 carries the common statement. The statement is in an orthogonal cutting experiment with a tool of rack angle 7, the chip thickness was found to be 2.5 mm when the uncut thickness was set to 1. The shear angle pi is given by option A 21.5, option B 22.5, option C 25.6, option D 30.1. Question number 25. The friction angle beta assuming the Merchant's formula holds good is option A 45.2, option B 51.3, option C 43.1 and option D 60.2. So here the angle rack angle is given as 7 degree and chip thickness is here 2.5 and uncut thickness is 1 mm. Okay, so chip thickness is given as 2.5 and so chip thickness ratio is here 1 by 2.5, that is 0.4. So using that the same formula that tan pi is equal to r cos alpha 1 minus r cos alpha, we can find out the shear angle. So shear plane angle and this angle comes out as 22.65. Okay. So answer is 22.65. Answer to question number 24 is B. And now according to Merchant formula we have 2 pi plus lambda minus alpha is equal to 90 degree. So that is for minimum power consumption, and so from this alpha is your 7 and pi is your 22.65 and lambda is your 51.3. So answer is option B. Okay. Next question number 26 to question number 29. A tube of 35 mm outside diameter was turned on a lathe and following data was obtained. Rack angle 35 degree, cutting speed 15 meter per minute, feed rate 0.1 mm per revolution, length of continuous chip in one revolution 60 mm, cutting force 2000 Newton, feed force 800 Newton. Question number 26 is chip thickness is option A 0.1932 and point B 0.1832, all are in mm. Option C 0.1652 mm and option D 0.1254 mm. The shear plane angle is 31.05, option B 30.015, option 33.05, option D 39.01. The velocity of chip along tool face is option A 6.3, option B 7.4, option C 8.17, option D 10.5. Coefficient of friction is 0.31, B 0.65 and C 0.42 and D 0.51. So here the given data are diameter of outer diameter of the tube, okay, and feed is given, okay, and cutting speed is given, okay, and length of continuous chip in one revolution. So assuming width to be same, uncut volume is equal to chip volume, okay, and L1 into T1 into W is equal to L2 into T2 into W, okay. So L1 is your pi d naught, because this is the uncut chip thickness, that is pi d naught. So pi d naught is your outer diameter, that is 35 mm. So from this we have uncut length is 109.595 mm and and uh, and length of continuous chip is given as 60 mm. Okay, so this is given as 60 mm. So from this L1 and L2 and T1 is also given. So T1 is uncut chip thickness is given. Feed rate is given and orthogonal cutting has to be performed. So feed we are assuming orthogonal cutting, and so feed will be your uncut chip thickness. Okay. So whenever it is not given, then we will assume that the orthogonal cutting is taking place and feed is equal to feed is equal to anchor thickness. Okay. So T1 is your 0.1 mm. So putting that value, we can find out T2 is your 0.1832 mm. So answer to question number 26 is B. Now the shear plane angle is your tan pi r cos alpha 1 minus r sin alpha. So R is your T1 by T2. T1 is your zero point 0.1 and T2 is 0.1832. So that is chip thickness is 0.546 and alpha is your 35 degrees. So putting that value, we can find out the shear plane angle. So that is 33.01. So answer is option C. Okay. And next is your velocity of chip along the tool face. So that can be found by velocity diagram. So that is VC, that is V, and that is in this direction. This is VS. So now this is your pi angle, and this is your 90 minus alpha, and this is your 180 minus 90 minus alpha minus pi. 90 minus alpha plus pi. Okay. So because we have to subtract these two angles, so addition of these two and 180. Okay. So this will be your 90 minus so 90 plus alpha minus pi. Okay. So V by sine 90 plus alpha minus pi divided by VC by sine pi. VC by sine pi and V by this angle, sine of this angle. So V is given as 15. So VC we can find out now. We have all the values. Okay, so we can find out VC. So VC is your 8.17 meter per second. Okay. So next, so answer is option C. 8.17. So next is uh, coefficient of friction. So coefficient of friction is again that is same can be found the Merton circle that we have found in previous question, that is F by N. So F by N is your mu, and F in terms of FC and FT is F sin alpha plus FT cos alpha, and N is your FC cos alpha minus FT sin alpha. So putting these values, we have FC, we have alpha, we have FT is 800, FC is 2000. Putting this value, we can get F as A1802 and N as 1180. So coefficient of friction is there 1180 by 1802. So answer is 0.654. So answer to question number 29 is B.